my project in this video. Before entering into the project, I would like to introduce myself. I'm John Britto. I have completed my BSc in Computer Science in Bharatiya University Distance Education, after which I joined in a company called Information Evolution as a senior research analyst. I have worked there for nearly 3 years. Currently, I'm pursuing DevOps plus AWS course in Qtree Technologies, Coimbatore. So that's all about me. Let's enter into the project. I built a DevOps project using Terraform, where I automated provisioning of AWS infrastructures, including a VPC, EC2 instance, and S3 bucket using a modular approach. In real-world environments, manually creating infrastructure in AWS console, that is creating it in console manually, is time-consuming. I solved this problem by using IAC, that is Infrastructure as Code, which is nothing but Terraform, to automate and standardize deployments. Let me guide you through the architecture of this project. So this is my project folder, Capstone Project. I'll explain it about the basic architecture of this. This starts with the custom VPC, which provides network isolation. So this is the root folder, main.tf, output.tf, provider.tf, everything inside the root folder. So inside the root folder I have another folder also called modules. So let me show you. So inside modules we can see that there are 3 different folders for creating 3 different resources, VPC, S3 and EC2. So I created a public subnet inside the VPC. Let me show you that also. Go inside the module. I'll show you the main configuration file here. So we can see that the main VPC is being created here, particularly for deploying EC2 instance inside the VPC and the subnet that we have created. So I have created a public subnet here, inside which an EC2 is deployed. Internet gateway has also been attached here, enables external connectivity. So the route table here created here guides the traffic in and out. So let me show you the EC2 instance now. Let me close this part. We make a command to edit the file here, the Terraform file. So this is the main configuration file for creating EC2 instance. I have created a EC2 instance here, down here. I have mentioned the AMI ID, instance type, subnet ID that I have created in the past. Subnet ID will be generated after deploying the project. That ID will be fetched here using this command line. In this file, the private key is being created to do a simple SSH from a CLI, and security group is also created. This security groups enables the EC2 is fully secure. That is, only the allowed IP addresses are let inside the EC2. For demonstration purpose, I have allowed every traffic to enter and get out of the EC2, and I have named my EC2 instance as EC2 secure. The security group as EC2 security group. And I have also created S3 bucket. Let me navigate to that part. So we can see that there are 3 different modules, and S3 modules is present here. Let me navigate to the S3 module now. Oh, this is simple. There are resources being created, that is S3 bucket, and the bucket variable. I've inserted a variable here which will be fetched from the root module. I have inserted the bucket name over there, so it will be easy for us to understand, and the file will be easy for us to reuse. So the name is variable bucket name. I'll show you the bucket name now. So I've given all the variables inside this terraform.tf vars file, like the necessary names and other things. Sorry, terraform.tf vars. Yeah. Here I have given the region for the EC2. The EC2 is created in this region, US East 1. The VPC name, the CIDR block for the VPC, the subnet name, and the CIDR blocks for the subnet also. This subnet is a public subnet, so that I can easily access the EC2 from my CLI. We can deploy the EC2 instance inside the private subnet also, but that is quite challenging for me to configure the files. Like I have to install not install, but I have to configure some other resources like the NAT gateway to enter into the EC2 instance. The instance type is created in three micro. This is a free tier thing, so I've created it in here. The instance name is Capstone EC2. So the key that we'll be using for SSH is stone key that will be stored as a PEM file here. The bucket name is John Capstone Terraform. This will be unique, so I have kept the name like this. Let me clear it for a clear view. So without further delay, let's deploy the file. For deployment, I used shell scripting. I'll show you the shell script also. So this is a basic shell script to run Terraform commands. Let me guide you through it. The workflow is simple. Terraform init initializes the providers and the modules that I created before. Next is the validate process. Validate is nothing but checking the syntax of the configuration files that you have been created. If that is misspelled, or if any of the for example, if I if um, if I misknowingly put a resource block inside the EC2 instance for creating something else, that will pop up here in the validate stage itself, so that no duplicate resources are created. So Terraform plan stages shows the resource, what resources have been created that will run the screen that we are seeing, and also it creates a state file after applying all the changes and creating the resources. This state file is helpful for us to see what changes have been made in the resources, and what resources have been created before, so that we can do some changes after we have created the resources if there is a need. Let me go back and deploy the project. So I've shown you the stages in the workflow of the Terraform project. So to make it simple, I have created a shell script, which I showed you now. So I'm going to deploy it now. So the file which is being deployed is deploy.sh, that runs all the Terraform commands in a single click. Yep, the initialization has been started. So by doing the project in a modular structure, it helps me in doing reusing the files, configuration files. That is, if I'm in a deployment team or I'm in a coding team, what I'll do is I'll do all the changes that I need in the file. I'll take this file, I'll change what all the resources that I've been creating. So I can change the name of the EC2. I can change the even the storage of an EC2. like this. So it is reusable and it is also easily maintainable. This makes the whole thing scalable also. So the challenges that I faced during running this project is I did not structure the sorry, I did not structure the directories correctly. So it ended up an error like showing uh, incorrect directories. So after ensuring the proper module, after ensuring it, I started running the project. And also, particularly, I have deployed the EC2 in T3 micro, the instant type as T3 micro, because that is free. And this T3 micro will not run on the availability zone called US East 1E. So I ended up in that problem also. I researched about it. I saw it in the internet, and after knowing this, I completed the project and I changed the availability zone. So after that, I have to reinitialize the Terraform and do everything from the scratch. So this deployment process helped me in running the project in a single click. So we can see that all the resources are created now. The EC2 is created, the VPC is also created, and the S3 is also created. These are the stats of the project. These things will be stored inside a file called state file. I'll show you the state file now later. Let's first connect the EC2 from here doing an SSH. Like you can see that the public IP is here of the EC2. The instant name is Capstone EC2. So S3 bucket name is mentioned here as I shown earlier. The VPC is also created. This is the name of the VPC that we have created. So let's cross this in the console now. I've configured everything before itself. I've configured the AWS credentials before in the bash, so that will be easy. Now I'll open the S3 also and the VPC in a different folder. Other instances, we will be having the current running instance. This is the bucket that we have created, S3 bucket. This is fully a private bucket. Defaultly, it is a private bucket. We can particularly attach this bucket to an EC2 instance, that is attaching it in the sense I can improve the project further. Let me explain you about that. So this is the VPC that we created. Yeah, you have created a single subnet that is public under this region, and the route table is being created. It shows how the network flow works. We saw the S3 bucket, and yeah, this is the bucket that is running now. These two are the this is the EC2 instance that is running now. These two are the previous instances that I tried during like slide before. So it is deployed in T3 micro as I shown this. The availability zone is US East 1B. Let's check with the public IP now. 44.2.11.62.189. 44.2.11.61.89. Yeah, the public IP is correct. So the resources is created. So let's try to SSH from here. If I let me check the PEM file quickly. Stonekey.pem. Yeah. -key.pem and EC2 use hyphen user. at this public IP. So it is asking for a confirmation, like this instance is created right now. So for the first time, it is asking for confirmation, and after that, it won't ask for any confirmation. Yeah, we can connect to the EC2 instance. You can see it here, and Amazon Linux. Okay. Because I have given an email ID for Amazon Linux. So it is created in Amazon Linux 2023 version. Yeah. Config. The command is also working. So we can see that this instance is working perfectly now. We can do SSH also. Let, um, uh, Let me conclude the project. Overall, this project helped me understand how real-world infrastructure is automated using Terraform. I also demonstrated how DevOps practices improved, the deployment speed, the consistency, and the reliability of the project. Like I can further improve this project, like adding a load balancer and implementing auto scaling for higher availability of the project, and use the S3 as remote backend for Terraform state file. Let me show you the state file also. No? Let's exit from the EC2 instance. So this is the root folder of my project. Let me show you the state file now. Yeah, here the state file has been created. Yeah, Terraform TF state. Terraform TF state. Yeah, yeah. Here we can see all the things that we have created. This is the state file, and this state file, keeping this state file here, it's vulnerable for EC deletion and something like that. So we can store this Terraform state file while creating the resources itself. So we can store this in the S3 bucket after creating all the resources. For this, a readily available S3 bucket should be present in the uh, project before itself. Like I have created S3 instance now, but before doing this project, I should do some changes into the codes and create a S3 before doing such kind of project, so that this state file can be moved to the S3 bucket. So we can use that as a backup, and it is more secure also. And I can integrate CI/CD pipelines, like I can do the same project in CI/CD GitLabs also. So that's all about my project. Hope you will like my project. Thank you.